Assalamu alaikum viewers. The topic of today's video is enthalpy or heat content of a thermodynamic system. So first of all, enthalpy is actually the thermal changes at constant pressure. So enthalpy in other words can also be stated as the total heat content of a system. Secondly, enthalpy is a state function. What does it mean to be a state function? It means that enthalpy depends only on the initial and the final value. Enthalpy is independent of how it has achieved the final state. So, enthalpy, the absolute value of enthalpy cannot be calculated. So, you cannot calculate the absolute value of enthalpy. You can only calculate the change in enthalpy, that is delta H. Okay? And the last thing is exact differential is calculated. So for enthalpy, you can calculate the exact differential. Why? Because enthalpy is a state function. And for state functions, you calculate the exact differential. And in case of the path function, you calculate inexact differential. So enthalpy is a state function. So that's why you calculate the exact differential. So moving on. First of all, as I've just told you that enthalpy is actually the heat content of a system at a constant pressure. So according to the first law of thermodynamics state that Q is equal to energy plus PV work done. So this PV work done is actually the work done on the system. So that's why it has a positive sign. Since we are taking pressure to be constant, so in that case, this Q will be equal to H. So that will become H is equal to E plus PV. Okay, so that's the heat content of a system in terms of enthalpy when the pressure is constant. Okay, so as you know that we cannot measure the absolute value of enthalpy. So we have to measure the change in enthalpy. And let's just say that the change in enthalpy delta H is equal to H2 minus H1. Okay, so first of all, let me write the value for enthalpy that we have just calculated from the first law of thermodynamics, and that was equal to E plus PV. Okay, so H2 minus H1. So first of all, you have to write the value for H2. H2 value will be E2 plus P2V2, and similarly minus H1. So I just have to write the value for H1, and that will be E1 plus P1V1. So now I just have to open the brackets, and that will leave me with minus E1, and minus plus becomes minus again P1 V1. Okay, so as you know that the pressure is constant. So as the pressure is constant, so I can write P1 is equal to P2 is equal to P. So in that case, first of all, I have to rearrange E2 and E1. Rearranging the E1 will go behind P2V2. And again, as you know that I can write P instead of P2. So I'm just going to plug in that PV2 minus PV1. So now E2 minus E1, this can be taken equal to del E, because that is the change in the energy. And again, you have to take pressure as common, and we will be left with V2 minus V1. And again, V2 minus V1 will be equal to delta V, and this here is delta H. So that means the change in enthalpy is equal to change in the energy plus the P delta V. Here, this is the work done on the system. Okay, so what happens if the work is done by the system? So in that case, we will take the equation to be equal to del E minus P del V. Okay, so that is the case in which the work is done by the system. Because as you know, when the work is done by the system, you just have to reverse the sign. You just have to take the negative value of the work done. So now, from first law of thermodynamics, first law of thermodynamics. So from first law of thermodynamics, you know that delta E is equal to Q plus work done. You know that change in energy is equal to heat plus work done, and work done is taken to be equal to P delta V. So this here is the work done by the system in case of the first law of thermodynamics. So now you just have to plug in this value of delta E here. Okay, you just have to plug in the value of delta E here. So on plugging in the value, I can get the answer equal to Q plus P delta V minus P delta V. So as you can see here, I have just plugged in the value for delta E here, and delta E has become Q plus P delta V. So P delta V and then minus P delta V will cut out, and I'll get an answer delta H is equal to Q, and in the subscript I'll have to write P because this Q is at constant pressure. So I can say that at constant pressure the heat content of a system will be equal to the enthalpy. Okay, so that was the value for enthalpy. So now there is some sign conventions with the enthalpy. So for example, let's just say that for a reaction, for a system, delta H has a positive value. Okay, so that means during the course of the reaction, the reactants has absorbed some amount of heat, and due to absorbance of some amount of heat, the enthalpy content, the heat content of the product is more as compared to that of the reactants. So I can say that heat is absorbed in that case. So this is an endothermic system, endothermic reaction. So in case when delta H is equal to negative, so I can say that H2 is less than H1. Okay, so in that case the reaction will be exothermic, because as you know that when H2 means the heat content of the product is less than the heat content of the reactants. It means that during the course of the reaction, the reactants has lost some amount of heat in the formation of products, because product has lesser heat content as compared to the reactants. So that means in the formation of the product, some heat is evolved in the reaction. So this means that this is an exothermic reaction. So that was all for enthalpy content. If you have any question, you can ask in the comments.